Hello, this old electronics fan. I'm re-editing my video because I left stuff out, and I also left the intro out. So I thought, well, what the heck. Everything I was doing, everything I was using is now put away. So you get to look at me. So again, welcome to my channel. This is Old Electronics Fan. I think I just mentioned that. It's a senile moment there, a senior moment, whatever you want to call it. I hope this is of value to you. I hope you learn a little bit. Every time I do these things, I learn something. It surprises me when you think you know something about a topic and then you actually have to experiment. You have to set things up, test it, and record it, and you discover that things aren't always what you thought they were, or they don't work quite the way you think they should. So, I'm revisiting the topic of testing capacitors with the VTVM and comparing it to the C3, because well, I'll mention it further later on in the video, so I won't go over that again. You'll find out in a moment why I'm redoing this. So this is new and revised, so I hope you get something out of it. I hope you enjoy it. Thanks for watching. And the reason I'm doing that is because of what happened with this thing right here. I thought I had fixed this problem with this, where if you put it, it's on 25 volts right now, if you put it to leakage test with nothing connected, that light would close. Obviously that's not what you want. I just did a video on what actually was wrong with this and why it was actually doing that. Which means that probably when I did the last video on this, this thing was not working right and it was not giving proper results. If you want to see what was wrong and what was going on, there's another video on the C3 and the weird problem that it had. So, right now I've got my peak hold meter here. That measures the capacitance of capacitors. We're going to be using that. My VTVM, my C3. There's other tools you can use, ESR meters and so on. But, a couple thoughts. Number one, how important is it that we are able to use a VTVM to measure capacitors quickly and reliably? Well, I could see that being handy for, say I wanted to try a radio, test it out, and I wanted to do a quick test on it to see if the capacitors, especially the key capacitors like in your audio output stage, are healthy or not. There are a couple little quirks about this. You'll notice that I actually have three a clip, a probe, and a probe. These two are tied together. And the reason I've done that is because when you're testing using a VTVM, you really can't have a charge on your capacitor. If you do, it's going to funk out. Occasionally I've tested on here and then gone back to this, and I've actually watched the meter go in the wrong direction, even after I ground it out and I flip the capacitor around and it behaves. Alright, so here's what we're going to do. This is a brand new 0.005, actually 0047 capacitor. And we're going to, my clip went away on me, come back here. Come on, there we go. So I'm going to just quickly ground this out, make sure that there's no charge there. And what you should see is that it bumps up, it charges, it goes to infinity. And notice now I can make this connection and nothing happens. Now I go and I ground it out, I go back. That's a good capacitor. This is my standard when I'm using this method to determine the health of a capacitor. This is my standard. If it doesn't behave exactly like this, then I would consider it to be a bad capacitor, and I'm going to show you why. Now, we'll take this brand new capacitor, we'll put it over here on the C3, just so you'll know that this is indeed working. In fact, I think I already showed you. I'm going to put all the way up to max. So if this thing is not working, that eye is going to close, and it doesn't. That tells me it's working like it ought to. By the way, it's probably not a bad thing to do if you have one of these. Crank it up to the higher voltage levels with nothing attached. Hit the control the leakage test and see how it behaves. If it doesn't behave well, then you may have the problem that I had with this one. And I have a video showing you what I found, which is really kind of strange. All right, brand new cap, 25 volts. And by the way, 25 volts on this thing is not 25 volts, it's 40 volts. 150 volts is about 127. I think 250 was around 190. 350 was around 304. 50 I think was around 380, somewhere around there. I'm off the top of my head. So these numbers aren't accurate. All right, so you notice that this behaves well. It worked well there, and now this is brand new. This is an old used capacitor that I pulled out of something. So let's see how that one behaves. Let's see here. Ground it out. Check. And that behaves just like a brand new capacitor. So we'll bring this over here. Oh, this is high voltage, very high voltage. Okay, I don't remember where I got this out of, probably an old monitor chassis. So we're just going to go all the way up to 450. And it's happy. Alright, so this is a used capacitor that actually passed the test on the VTVM and told me for sure that this was a decent capacitor. Now, we've got a few capacitors over here, and I have over here my peak meter, and I've measured these two capacitors, the new ones that I just showed you, and they're accurate. They're where they're supposed to be. Because there's two measurements that you really want to be concerned about. Two key measurements, I should say. One is it leaky? You could call it ESR or whatever you want to call it. Or you could, and you also want to know what is the value of the capacitor, because both of those together tell you whether or not you have a decent capacitor. I've tested both of these. They passed the VTVM test and they passed the peak meter test. I mean, with brand new caps that behave the way these do, you don't really need to do that. The reason I mention this is that there are times when you have a capacitor that tests fairly well on the VTVM. So then you ask me the question, okay, should I use that? Well, let's check this out. So here we have, this is an infamous bumblebee, very infamous. These things are noted for not being very healthy as they age. Alright, so here we go. Alright, so that's about 100 megohms. Now, I think you can see, you can just barely see it on my, see, that's not moving very much. It's moving ever so slightly. I don't even see, I think you can see it in the camera. So this is checking out fairly good, especially for a bumblebee. But it's not going to infinite ohms. And looks like my zero is my ohms adjust is acting up a little bit again. Okay, let's try this again. Ground. Okay, so this is testing pretty well. So let's see what the C3 says about it. And we'll hook that up, and we're on 25 volts, or we will be. There we go. See, it's not opening all the way. So that tells me that this thing is iffy. So now we're on 150 volts, and it just is closing all the way. It's dead. Now, on my meter, it's 127 volts that's being applied across this. And it's leaky. Now, sometimes if this was being used for a coupling cap, you might be talking 40 volts. You could, somewhere around there. It could be different depending on the circuit design, but so this thing is so-so at 40 volts. What that says to me is that this thing is probably passing DC voltage. Not a lot, I'll be honest, but it is. So let's go back to, and we'll just make sure there's no charge on there. So we're going to check this with the our capacitor meter. Okay, so this is supposed to be 003. All right. And it's 0037, so it's almost 004. So this has almost doubled in value. It tested okay on the VTVM, not so hot on the C3. It fails on the value test. So this is a junk capacitor. So let me stop for a minute and say, okay, well, would you want to be bothered with doing that? Well, again, remember if you're in a circuit where you can test this in circuit, then you grab your meter, you get a reading off from that, and you say, I don't know. You grab your capacitor meter, you put it on there, and you find out, yeah, no, that's bad. So let's check out this guy right here. Actually, I'm going to try this one. So I know these are pretty bad. Let's see. All right. So why you keep moving on me? I think my control has gone south due to old age. All right. So here we go. Paper cap. This is supposed to be 0.005. So let's see. All right. So that's pretty poor. So if I were testing a capacitor in circuit and I saw this, that would be immediately no-go. It's getting up to just shy of 50 megs, thereabouts. And you can definitely see what's happening when I let off from it. It leaks badly. And so if I go over here, that's on 25 volts, and this is a 600 volt cap. All right. So 40 volts. All right. So that looks surprisingly good. And that not so hot. So that's 127 volts. If I go to 250, yeah. So as far as I'm concerned, this is a bad cap. So what does it measure on my meter over here? Alright, so this is supposed to be 0.005. Alright, so let's go, I'll start here. And, come on. That's 0.007. So let's go over here and see what we read here, if it will give me a better number, or better. Okay. Yeah, 0.008. Supposed to be 0.005. So that's way out of value. So it leaks and it's out of value. So we'll try another one. I also know that this one's not very healthy either. Alright, so although it's better than some. Okay, so that's just shy of 100 megs, maybe 90. Alright, so we'll put this over here, and now 40 volts is okay. 127, not good. And if you go up to that, it's definitely not good. So again, so what's the value on this thing? It's supposed to be 002. And what do we have here? Yeah, Whoa. Maybe dancing around there a little too much. Yeah, it's more than doubled in value. Bye-bye. Now, the last two, I know these are not horrible. This is an oil-filled paper style cap. And so we'll check this one out. And this one's climbing up to 100k ohms. And you can see the needle moving a little bit. So this one's not horrible, but it's not new, definitely not new, and it's, as far as I'm concerned, it's probably not really healthy enough. So this is a 400 volt cut cap. That looks good. It opens a little bit at the 150 scale, but you hit 250 and it's gone. So, is this okay? Well, let's find out. Let's put it on our peak meter here. Just make sure this is supposed to discharge them. It probably does, but hey, who knows. And this is supposed to be an 05, so let's go there. Alright. So the value isn't bad. And it's very close to its correct value. And so in a low voltage circuit, it might be okay. But if it were something I were going to use all the time, I wouldn't use this. It's not behaving like a new capacitor. It does have some leakage. Granted, it's not much. The value is actually pretty good. But as far as I'm concerned, unless it was something I would use very rarely and I knew that the circuit wouldn't be pushing it voltage-wise, again, if you're only talking, 50 volts, 60 volts, somewhere in that range, 70, and it's not in some place critical, then this might be okay to use. If it were in the position as a coupling cap to your audio output tube, no, I wouldn't use it. It's already starting to leak. It's not going to get any better as it ages. Okay, this is an addendum. So I was thinking about how do I want to put this? Well, I had a feeling that there are going, well, I know there are going to be people out there, oh, you're crazy. The capacitor that measures 100 megohms is not going to pose a problem in a circuit. I have a capacitor, it's a 0.01 microfarad, and it is in, and I'll show you this in a minute, it is in, it's a coupling cap between the 12SQ7 and the 50L6 in my airline radio that I just finished repairing. Now I want to show you what this is doing. So right now I'm grounding capacitor out. Now watch. Now it takes a while. So right now it's up to 50 megs. It's slowly climbing, and it's almost on 100 megs. The angle of the meter isn't showing it to you, but that needle is actually on 100 megs right now. So now let's show you. See, I put everything back on my shelf where it was. Oh, did I not turn this on? I thought I did. I did not. Aha. That's bad. Alright, well, while we're waiting for that to come up, this is the bumblebee that I'm talking about. Now I selected certain ones for this test, and this is one that I left out of the test. And I was pondering this, you know, this is a perfect illustration of how useful this VTVM is, and the fact that it demonstrates that the high ohm capacitors really do pose a risk. So let's see, where am I? I want to bring out something that makes it, that will hopefully make it easier to read. Yeah, here we are. Okay. So while we're waiting for that, I wish I thought to turn that on. I simply forgot. Oh. Okay. This is my chart. I don't know how well you can see it. I did enlarge it. So the 12SQ7 is feeding signal to the 50L6. And the pin 6 of the 12SQ7, which is right here, you probably can't see that. This says it has 55 volts on it. I think it was more like 60 when I measured it. So, so 55 volts is traveling from this pin to pin 6, yes, to pin 5 over here on the 50L6. And that means it's going through this coupling capacitor, 0.01 coupling capacitor. When I was checking this radio out, remember I mentioned I was going to do some things, and I was going to check, and then I was going to change capacitors and so on. Well, I did check the voltage on pin 5 right here, and I was getting around 3 volts on this pin, which is not good. It's not horrible. I mean, it's supposed to be, pin 5 is supposed to be, pin 5 is supposed to be 0. And it is 0 now, which is good. So 3 volts, not good. It's overdriving the tube. Is it going to toast the tube? Yeah. I wouldn't want to run it very long like that. Okay, so I think my C3 is now decided to join the party. Let's see, where are we? Okay, there we are. And I don't know. I guess we're going to zoom in as much as we can. Hopefully you can see. Maybe I can shadow that a bit. I can do this. There. I think maybe if I zoom in a little bit. And let's see. Yeah, I think we can see well enough. Okay, so right now this is on 25 volts. And hook this capacitor in. And I'm going to do the leakage test. And you can see the eye isn't completely closed. I go to 150 volts. It's closed. Solid. So the 25 volts is actually putting out 40, as I mentioned before, and the 150 volts is about 127. So at around 40 volts, the eye is partially closed, which means there is some leakage. And at 100 and 127 volts, it completely closes. So my point is fairly straightforward. Let's get back out here and throw some more light on the subject. So I think this should make it clear that even though this capacitor measured about 100 megohms on my VTVM, it's not safe to use in a coupling as a coupling capacitor. It's leaking enough DC voltage to start overdriving the tube, and I guarantee you these capacitors don't improve with age, as we see over and over again, and occasionally they go bad, overheat, and split. I showed you one of those. So yeah, so I think I don't think I'm off when I suggest that capacitors that measure 100 megohms on my let's see, I'll back this off. I guess I am off. Can I put myself in there? All right. So all I can say is that these old capacitors are a risk to our old electronics. And I know some people think if they're down around 20 megs, they're safe. I don't think they are. And I think it's clear if you take something like this out of a circuit and you know for a fact that this was allowing enough DC voltage to go through to overdrive the tube even a little bit, it's not a good idea. So for what it, you can take that with a grain of salt, but that's what I have seen, that's what I've experienced, and that's why I believe that my testing with the VTM actually works. So back to the regularly scheduled program. And then lastly we'll do one more. This one is actually a relatively low voltage cap. And this one, just kind of curiosity, this one I took out of my Webcore tape recorder that I was working on recently. And that was not going anywhere. Why are you, I gotta check that control line. I know I've cleaned them. Why are you misbehaving? Now this one's actually checking out pretty good. That way. Yeah. So let's check it over here. This is 50 volts, so I can't go above the 25 scale, especially since it's already putting out 40 volts. And so this passes the test pretty well. And so I might keep this around just in case I need one. Let's check to see what the value is, because that's my second test, and I want to know, whoops. Now I replaced it because of how much work it was to, oh come on. Okay. Now I replaced this because of how much work it was to get to that. And this is supposed to be 0.25, come on. Stop dancing on me. Yeah, alright. So, this capacitor tests pretty good. And I have another one like it, and I think it's testing the same way. What's the brand? Chicago, oh, Sun. So, this one isn't horrible. I mean, it tests pretty close to a new capacitor on that meter. The value's right where it should be. Probably didn't need to replace this then, but again, because it's an old capacitor, and on my Webcore tape recorder, it's a lot of work to get to the circuit board where this thing was. And I expect to use this thing from time to time, so I didn't want to take a chance, so I took this out. But probably I didn't need to do that because this is probably okay. So I just throw this out there for your consideration. Is it useful? I've found it to be so. If I just want to quickly go through, I want to test a radio. I want to find out, is it safe to turn it on? I can quickly test certain capacitors within it and come to a decision. If I'm seeing it hitting in between the the 20 meg and the 50 meg range, I'm not going to run the radio if it's at that level, or worse than that. If it's up around 100 megs, I know I can at least test the radio, and I don't have to worry about it. And to me, it's also a good way to test to see if capacitors are worth keeping. My mindset is typically when I'm restoring a radio, especially for something I know I'm going to play more than once in a while, if the capacitors don't test like a brand new capacitor, they get replaced. And sometimes, depending on how much use I think I'm going to be putting it to, I might just replace them all anyway. So is there value in this? I think it could be useful. I have used this. I have left capacitors in radios because they passed this test. So it saved me the trouble of taking the capacitor out and testing it on my C3 or whatever, because that told me what I wanted to know. And on a couple of radios I've encountered, the brand I think is IMP. Is it IMP? I think so. Black capacitors, IMP Pyramid plastic capacitors. They look very similar to these, but so far all the ones I've run across in the old radios that I have tested at or near new. Nothing like these things. These are horrible. I don't know what they did wrong when they were making these, but whatever they did wrong, Pyramid actually did right, because I actually have a Pyramid in my little airline radio. I had it through it in my junk box, realized I didn't have that size capacitor, so I threw it in my my little airline radio because it was testing like a brand new capacitor, even though it was rather old. So I'm taking a chance, but that radio will probably get used once or twice a year, and so it works out well. I don't have to worry about it dying on me because it's not going to get used a lot. So anyway, I hope this is helpful to someone. If you get something out of it, that's my only reason for putting it on here. Like I said, I did revise this because this thing was not behaving the way it was supposed to. It was lying. I did not know that, and so now I realize, well, I'm hoping, I've replaced pretty much all the wiring in this thing, so I'm hoping from now on this thing will behave itself. But it probably wouldn't hurt as a quick test before you attach a capacitor to your C3 or any capacitor tester. Leave your leads disconnected from anything and check to see if it's responding correctly. If it is, go ahead and test. I wish I had had that as my standard test before I found out the hard way that this was not working right. And I forget what triggered me to test it or check it again. But I was comparing, I think maybe I was doing something like this, comparing, again, just playing around, comparing the VTVM to this, and the results were puzzling to me. That's when I said, has this thing started acting up again? And it sure had. So, again, I hope you got something out of this. I have fun experimenting with stuff like this. Maybe trying to find ways to do things that maybe saves me a little bit of time and trouble. I don't have to build or buy anything. I already have a VTVM. And if I can read my capacitors quickly and easily using that, at least get a sense of what their condition is when I'm checking out an old radio. And the other nice thing about this is if I try testing capacitor in circuit and I get that, then I know that there's something else in the circuit. I get a resistance reading other than the capacitor charging and then reaching equilibrium. Then I'll know that I can't test the capacitor in circuit. So that's also useful. So I know I have to test it another way. So anyway, so I'm rambling on. I will stop rambling. Again, I hope you enjoyed this. Hope it was useful. And if you have any comments, put them down below. And hope Hope to see you on my next video.